In this video, I'll show you how to build this 4-axis robotic arm. This is a 3D printed product and it's open source, and you can build this yourself at home. I'll put a link to the source files in the product description. Okay, let's take a look at this a little bit. Here in the front, you're going to need an Mk2. You can use plastic gear if you want, but I chose the metal gears. But it's the size that you're looking for. This is the micro. So in the back you have this servo motor controlling this arm, which moves this up and down. And then you have this servo controlling the main arm right here. And then you have another servo turning the whole robot right and left. So those three are all the same. And I use the MG996R. Now the nuts and bolts, there's a parts list that you can download from the designer, and then I could not find all the metric bolts, and so for all of these connections here, 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 and here, and here, I used a number 8. And I just got a variety pack, and most of them are 1 inch, except for this big one right here. And I could just barely get a 2 inch, but I think that you should really do 2.5 inch if you're going to use imperial here. Otherwise, you can just use the metric one specified in the design. Now, for testing purposes, I actually bought 4 of these, but I also wanted to test my Arduino, so I currently have the gripper with potentiometer here, and then I have forward and back, up and down, and then right and left. And these are just to debug it. And so I wanted to test it with these simple little testers first, and then to control it, you can stay tuned for the next video, subscribe for updates, and I will go over how to do this in a little bit more controlled, less prototype fashion. So the first thing you need to do is determine whether or not you need to scale this in your slicer on these parts or print them as is. So I'm using PLA, and PLA shrinks a little bit. So I printed one of the smaller parts out in the claw that holds a micro servo, and then I measured the opening and the distance, and for me I needed to increase my scale about 2%. So I scaled everything 2% from there. And then I reprinted out that same part and did a test fit, and it works just fine. So depending on the material and your printer settings, you may or may not have to scale. Alright, so the next thing I did was started printing out the base parts, and when those were done, then I printed the ones that needed supports. And so there are 4 parts that need support. The first is part number 2, the main arm. Part number 3. Part number 7, and part number 6. Now, to save time in this tutorial, I created another tutorial showing exactly how to do that with this first part. So I will put a link in the upper right hand corner and you can go look at that. Now for the remaining 3, I had to put this at a 20-degree angle in order to get it on my plate. And so that's how I printed the remaining parts that needed supports. Alright, we have the base part here, and so we have to do a couple things in order to make this work. So these are, this is a 3mm nut, and we need to put it in these slots so that we can mount this upper plate on. And what I found is that this is just too tight. So take your nut and push it in there, and here I've fixed the hole. You see I can start it, so I know that this is going to go in there. But the other ones I have not done yet, so I'm just going to pop that out. And then if I try it over here and I press, then it won't go in. Now, due to the way these are recessed in there, it's really hard to get anything in there. You might try a knife, but see, the problem is that the knife doesn't work real well, can't really get in there. And so what I've found to do is I can just go in here manually with a little drill and just run it back and forth very hard to show you with, because it blocks the camera view. But you can go back and forth like this and work out those sides, and it goes all the way through, and you want to try and get it as square as you can on both sides, and keep doing this until you can get the nut in. Alright, so the nut is starting to go in after I've been working it for a while, and I'm going to press that in a little bit later, but I want to make sure that all three of them will work before I press it in, because I don't want it to go in halfway and then not be able to get the nut out. So I want to make sure I can get that in. That one's a little tight, so that needs some more. Now this one doesn't go all the way through, okay, on this end. So you have to best you can try and clean out those sides so it has enough width. And just keep doing it until you can work out enough of the plastic to get it wide enough to slip that in there. Okay, the next issue with the base here is that we have trouble getting our servo motor in for two reasons. For one, there are no mounting holes. Alright? And the second thing is that you need to mount this with this drive forward, and there isn't a slot here, and you can't do it from the bottom, and the slot only goes halfway up. So we'll be forced to take this off and try and get this on. So just grab a little screwdriver. Okay, so we've got the cover off. I'm assuming that's going to fall apart, so I don't want to take the whole thing off. Now we can just put this forward, slide this down and the wire down. Okay. Yeah, it's a really tight fit. Okay, so I have the motor installed, and I'm going to try and very carefully drill it with the motor in place and see if that works. And then I'm going to lower this so I can get my drill bit out. And now I believe that'll work just fine. I only did it is I just pierced the top layer because with a 30% infill, I don't want to drill too much. I just want enough that I'm not going to break this top one. I'm going to take a knife and I'm going to trim a little bit of the underside here and put a little bit of a chamfer on that so that I have enough room to put that cover on from the bottom. Okay. Gently slide that back on again. It's a pretty tight fit. I'll have to try it. Okay, I just barely have enough room. Okay, so you can see my little chamfer that I put on there. Okay, so that's mounted, and then I will put all these screws in. Okay, our servo is installed. So in areas where you can't get the screws to go all the way through, here we go through the top, it won't go through the bottom. You're going to have to drill them out. And then test and make sure that they go in really well. There we go. And almost all the holes are just a little bit too small. So you just make it a habit to kind of clean them all out. Okay, so we're ready now to install this base plate. So there's a bearing that goes in here, and I can reach this from the bottom. And so then we put our ball bearings in here, and this mounts right here. So I'm ready to press these nuts in. You can just slide them in and then get a little screwdriver and then look down the hole and then stop just as soon as you can see it. Okay, get this last one in there. Okay, and we'll slip this in here and then put these M3 screws in. And it'll look like this when you're done. So all these servos on the bottom need to be in the neutral position. So just grab one of these little testers. They're like $2 or $3 or something. Put it in the center position, which is neutral, and plug it in, and then it will automatically go to the neutral, and then disconnect it and assemble it into the robotic arm. Okay, in here, I believe the instructions called for a metric bolt. Well, I know they did. But I couldn't find it, so I put a number 8 lock nut in here. Alright, so here we're going to insert two M3 lock nuts from the back side. Okay. Now these are M3 by 25 screws. They come in this way, and they'll thread in to those lock nuts. Okay, nice and snug, they don't protrude. Alright, now here's some 304 number 6 stainless steel ball bearings. You just fill this up. Okay. So this round horn needs to be attached. There's some pre-drilled holes, but there's no mounting hardware specified. So I just drilled a little hole, and I've got a little number 4 screw here. Let's see if this is long enough. Yeah, that's going to work. So that's a little 4 by 1/4. You might be able to, I also have a 3/8. But that'll keep it from spinning. Next, just take the gear and just press it into the servo motor, and then put the screw that came with the servo motor and attach it. And put this on. Line those gears up. I'm going to pause the video right here because I actually put this on backwards and I created a bunch of steps after this. So I'm going to continue with this and then I'll swap it later. Okay, so they're engaging, and then hold this. I've got the bearing in there. Okay, and adjust this so we got about the right tension, a little bit of slack, but not too want to bind. Okay, I have my Arduino here with a potentiometer. So that works pretty smooth, so I'm going to go on to the next step. Okay, so we're ready to move on, and we now have these two arms here, and they go on like this. And so here you can see a place for the horn on this one and a horn on this one, and these work independently of each other. And so the designer said put threaded rod in, and I'm not going to do that. I'm just going to use some 1/8 inch rod. Basically we just need a shaft, and so it needs to go from that surface right there, okay, to this surface right here. So I'm just going to insert it in, get it flush here like that, and then I'm just going to mark it. Alright, I'll go out to the shop and cut that off. Now the next thing is that my kits don't have a single arm, they have a dual arm here and there. So I'll just go out to the shop and cut those off as well, all at one time. Alright, so these are now centered. And here is my little shaft. You can test, make sure I got that the right length. Okay, so we're going to push this in. We'll put our shaft in. I'll push it all to one side. And I'll find that hole. Alright. Now we have two of the, and I'm using the Mk2 So this one goes about horizontally. So that would mean put this at a 90. Press that in there. I'll put in 2 screws for now on the top and the bottom, and then I'll finish that up when the entire thing is ready. Now for the left side, we're going to take the servo motor and then put the arm in vertically and press that in, and then attach it in the vertical position. And then we'll put the arm in, and then we'll slip that in there. Okay. Now just attach your screws on this side and then add the remaining screws on the other side if you haven't already done so. Okay, now as I mentioned before, I put this in backwards, so I'm just going to remove this bottom bolt and flip this around 180 degrees according to how it was designed. Okay, so we're ready to move on to the rest of the assembly. So the next 3 parts we're going to need is this angle bracket, and then these 2 arms. One is a little bit shorter than the other. Okay. The shorter one goes on the bottom, and the longer one up on top. So we have these two arms right here. There's one in the back and there's one in the front. So the angle goes right here, and I already have the screw inserted. And I'm using a number 8x1 because I couldn't get any metrics. Okay. Now with the flat side that way, slide this in here. And this is also number 8x1 if you're using Imperial. Okay. Now we can put the lock nuts on in a minute. The next is this piece right here. So this one goes over the first one here, and it just slips on one arm. Okay. We'll just set it there for a second. And then the next one is the tri-link. And so we're going to put the bevel this way and the flat side out. And then that, I'll turn this a little bit so you can see it. Turn the camera up a bit. So that will slide between this one and this one. So I think the easiest thing to do is to start the screw. And so I didn't have metric again, so this is a number 8x2. Got that started. And then now I'll slip this in and I'll turn it towards me so I can see it through the hole. Okay. Like that. Okay. Now this one's really short, but I have just enough to put my lock nut on there. But it's pretty tight, so I really think that should be 2.5 inch, so I can swap that out at any time. Now, this one with the angle connects to one length of the tri-link. And this one here connects the other. And we can put our lock nuts on there. And turn this one around the other way. Now go over through all these and tighten these nuts and make sure that you have adequate movement, but it doesn't bind. Okay, so now moving on. The next one is the front tri-link. And so we're going to put it in this orientation because we'll put the claw in this way into this little dovetail. And so with the flat side here and the projection that way, so this is an 8x1 1/4. Okay, now the longer link here, we're going to put the one that's tapered in front. Pull this back. Slip that in there. Okay, here's the gripper. And the way this works is that you put your little SG90 in here, and you have your right and left gripper in this drive gear. And then you have a little horn and a gear that goes on here. Well, the issue is there just isn't enough room. It doesn't stick up high enough. And I've seen some other builds on the internet, and it looks like this is a common problem. So, you know, maybe the dimensions are different from the way it was designed. I don't know. But that won't work because it won't reach. So if you look at how much it takes in order to get it to align, it's roughly the thickness of this little tab here. So one thing I could do, and I think I might try, is just go out the shop, and if I just take out this much on each end, about that deep, so it'll go about halfway deep, I'll still have enough material to screw this in, as long as my screws don't protrude forward. So this screw is no problem, because if it went through, it would clear. So that's not an issue, the front screw. The back screw looks like it will interfere with the gear. So what I could do is cut that off, but it's just not going to work, and there just isn't enough room. So I'm going to mark that. I'm just going to mark it with a pencil. It needs to go to there, and the front one needs to go to there. Okay, so that's how much I need to chip out. And do it the width, so basically it's going to be the width of the opening, just right here. Okay, so we'll try that and see if it works. If it doesn't, I can always reprint the part. Okay, I've got several different tools. One other thing I want to do is carefully mark it. I don't want to go so much that I break this. Couldn't find my Dremel. I don't have any idea where it is at this point. That would probably be the easiest way to do this. Plastic's a lot harder to work with than wood. Wood, I could just chip it out. Okay, so the one side's down. I got that quite a bit lower. Take a little bit more out of this front, I think it might work. Okay, so now this is flush. So we're down the thickness of these tabs. Let's see if there's enough room. So now there's enough room, okay? So what I'm going to do is I'll cut this arm off. Okay, I'm back inside. So with the drive gear forward, this one we know will go in and it'll pierce through, but it's not going to matter because it doesn't interfere with the motion. At least I don't think it does. Okay, so that's flush. Now the one in the back, so you can see that the screw is just sticking out, and I'm afraid on the back I think that'll interfere with the gears. So what I do is I can grind off that tip, or if I have a pair of dikes in here. If you're doing something like this, wear safety glasses because this will go flying for sure. For trim into length, just install it into the plastic. Put your two screws in, and then so the little claws go the other way. So in other words, flip it over like that. Slide this in there, and then to align them, you might have to do it a time or two, but you can open them all the way and then thread them in like this and confirm that you have it correct. Alright, and when it's correct, go ahead and put your lock nuts
on here.
And then tighten them down.
And carefully adjust this so we can reduce the amount of slack without it binding. Okay.
Now slip the gear with the horn down onto the servo motor and attach it with a screw. Now hook it up to your servo and test it to make sure it works.
Perfect. Alright. That works nice and smooth. And that it's lined up pretty well.
Now put an M3 lock nut in the gripper and then slide it forward onto the tri-link. And you may have to remove this like I did in order to get that to line up properly. And then tighten the screw down. Then just reinstall that bolt to the arm there and put a lock nut on there. So the basic assembly is complete, and the only thing I have to do here is print out this cover motor, and I can do that at any time. So now it's time to test it and make sure everything works correctly. And I like these little servo testers. I'll put a link in the description below, and they're really inexpensive, but it's a great way to see if it's working or not. And stay tuned for updates. In the next video, we'll build some sort of control system to make this a little easier to use.